In this video, I'm going to go through the first of my tricky parts per notation questions. The first one reads, hydrogen sulfide has an odour threshold of around 500 parts per billion V over V. What is the concentration of the threshold in moles per decimeter cubed? So the equations and other things that you need to solve this question can be found in my blog, which will be found in the video information. The title of the blog is An Explanation of the Parts Per Notation for those who are already familiar with mole concentrations. Please visit this blog to help you with this question. Okay, so to start with, what we need to realise for this question is that because hydrogen sulfide is being smelt, it means that hydrogen sulfide must be a gas. Now, hydrogen sulfide, 500 parts per billion is not a lot. So this hydrogen sulfide is going to be behaving as a perfect gas. So this means that for every 24 decimeters of hydrogen sulfide, we're going to have 1 mole. Okay, this is an intrinsic property of ideal gases. So the molar volume, Vm, of hydrogen sulfide is equal to 24 decimeters per mole. And we can write this as being the volume of hydrogen sulfide divided by the moles of hydrogen sulfide. Now, the next thing we need, and this can be found in my blog, we need the equation for parts per billion in V over V. And this is, for hydrogen sulfide, it is the volume of hydrogen sulfide divided by the volume of air, because the hydrogen sulfide in this case will be dissolved in the air. And this would be times by 1 times 10 to the 9, because 1 times 10 to the 9 is equivalent to a billion. And this will be equal to our 500 parts per billion. 500 parts per billion. Okay. Now, what we need is the concentration of hydrogen sulfide. So we need the concentration of hydrogen sulfide, which is equal to the moles of hydrogen sulfide divided by the volume of air. So it's how many moles there is in a unit of air. Okay, and this is equal to our question mark. So we need a way of going from this equation to this equation. And we can do this by using our molar volume equation. So what we do is we rearrange the molar volume equation in terms to make VH2S the subject. So VH2S is equal to 24 times the moles of H2S. And then we can insert it into our parts per billion equation. So 24 NH2S divided by V air is times by 1 times 10 to the 9 is equal to 500. And you'll see that we're already starting to get our concentration in this equation. So now we just need to rearrange it so N over V is the subject of our equation. So H2S concentration in moles per decimeter is equal to N H2S over V air, which is equal to 500 divided by 24 times 1 times 10 to the 9. Now, if we put this into our calculator, we get 500 divided by 24 times 1 times 10 to the 9 is equal to 2.08 times 10 to the minus 8 mole per decimeter. And this answers our question.